Imagine betting your entire career on an idea everyone else thought was a complete joke. Well, in 2012, three researchers did exactly that. They didn't have a massive corporate lab or some multi-million-dollar supercomputer. They had two standard gaming graphics cards, a concept the rest of the computer science world had basically written off, and just a few days to literally change the course of history. We're diving into the ultimate tech underdog story today because what these guys pulled off is the exact reason our modern AI world even exists. To really get why this matters, we kind of have to travel back to the dark ages of artificial intelligence. In 2012, AI was, frankly, a punchline. Betting your academic life on something called neural networks was widely considered career suicide. But our outsiders, Krizhevsky, Ilya Sutskever, and their professor Geoffrey Hinton, they just stubbornly refused to let it go. They knew something the rest of the world was completely missing. See, for decades, the standard approach was just humans typing out thousands of rigid, hand-coded rules to teach a computer. You'd code, cats have pointy ears. But then that breaks immediately, right? Because bats also have pointy ears. So you add, cats are small, but so is a shoe. It was a total mess. These systems were unbelievably fragile. But this controversial neural network approach, it threw all those rules out the window. Inspired by the human brain, it learned just by looking at examples. But to prove to the haters that this actually worked, our underdogs needed an arena. Part 1. The Impossible ImageNet Challenge. Every year, the top computer science labs on Earth would gather for this absolutely brutal, unforgiving competition. The task was mind-boggling. They had to sort through 1.2 million high-resolution images. And we're not talking about just saying, hey, this is a dog. The AI had to look at brand new images it had never seen before and categorize them into 1,000 hyper-specific buckets. It had to accurately distinguish between 100 different specific breeds of dogs. And honestly, look at the visual chaos these systems were dealing with. We've got mites pushed way off to the side of the frame, leopards totally camouflaged in tree branches, obscure mushrooms, weirdly focused cherries, a dozen types of pumpkins. It's a lot. And at the time, the absolute best state-of-the-art systems, the ones not using neural networks, were failing on more than 25% of these images. They had completely hit a wall. So, how do three guys in Toronto break through? Part 2. 4 tricks that changed everything. To conquer this absolute mountain of data using plain old gaming hardware, they engineered a secret arsenal of 4 specific tricks. And what's wild is that almost everything they built into this 60 million parameter network is still powering the AI you use today. So trick number 1 is called ReLU. Don't worry about the heavy math, just think of it as a brilliantly fast switch. Old-school artificial neurons were smooth, but they were painstakingly slow to train. The team just swapped them out for a ruthless, simple rule. If the incoming signal is positive, pass it through. If not, shut it down to 0. Boom. It sounds almost ridiculously simple, but it made training the network significantly faster. Without that fast switch, they wouldn't have even gotten off the starting line. Trick 2 is dropout. Now, with 60 million parameters and only 1.2 million images, the network was so massive it started cheating. Basically, it was just memorizing the pictures instead of actually learning what made a cat a cat. It's exactly like a student who memorizes an answer key instead of actually reading the textbook. Their fix for this was genius. During training, they just randomly switched off half the neurons. This forced the network to never rely too heavily on any single pathway. It forced actual learning. And honestly, it's still one of the most essential machine learning tools today. Okay, trick 3 was just pure, scrappy resourcefulness. Data augmentation. They simply didn't have enough training photos, so they literally manufactured more out of thin air. They take a photo, flip it horizontally, crop a tiny patch out of it, or slightly tweak the colors. To us, a flipped cat is obviously still just a cat, but to the neural network, that registered as a completely brand new, computationally free training example. This one clever trick multiplied their training data by over 2,000 times. It completely saved the system from memorizing the data. And trick 4? This might literally be the most consequential move of all. Splitting the brain. The network they built was just way too big to fit on a single GTX 580 graphics card. So they made this wildly rebellious decision to split the entire 60 million parameter network right down the middle across 2 gaming GPUs working in parallel, only letting them talk to each other at specific layers. This improvised, desperate decision to use gaming cards for massive AI calculations? Yeah, that accidentally birthed the entire modern AI chip industry. Part 3. The shocking 2012 victory. So they had their tools, they have their augmented data, and they set those two gaming GPUs to run. For 5 to 6 straight days, the machine learned, non-stop. You can practically feel the cinematic tension in that lab. And when they finally submitted their results, the data absolutely shattered the computer science world. The second best entry that year, which was the absolute peak of the old hand-coded way of doing things, had an error rate of 26.2%. The Toronto team's neural network, 15.3%. They didn't just win, they humiliated the competition. They cut the error rate almost in half in one single leap. The gap was so insanely huge that judges actually thought a mistake had been made. But there was no mistake. Today, researchers just call this the ImageNet moment. This single, undeniable victory took deep learning from being a complete joke, a fringe, crazy academic bet, straight to being the absolute future of global technology. Practically overnight, every major tech company on the planet started scrambling to catch up to what 3 guys pulled off with a couple of gaming graphics cards.
Part 4. The billion-dollar AI aftermath.
Fast forward to today, and the validation is just staggering. Geoffrey Hinton, the professor who stubbornly stood by neural networks when no one else would, just won the 2024 Nobel Prize in Physics for this exact foundational work. We literally call him the godfather of AI now. Ilya Sutskever, he went on to co-found OpenAI, helped build ChatGPT, and then launched his own company. And in 2026, NVIDIA invested billions into Sutskever's new venture. The crazy part? NVIDIA's CEO explicitly pointed back to this exact 2012 paper as the reason why. Over a decade later, the shockwaves of this paper are still dictating the multi-billion-dollar moves of the entire tech industry. Part 5. The AI in your pocket. You really don't need to work in Silicon Valley for this 2012 paper to affect you because it already has, deeply and irreversibly. Every single time your phone unlocks just by scanning your face, that is the direct lineage of this paper. When Google Photos magically pulls up pictures of your dog without you ever tagging them, same exact lineage. Doctors using software to spot tumors, self-driving cars navigating around pedestrians, and yes, even massive language models like ChatGPT that are actively reshaping our world right now, all of it traces straight back to that cramped lab in Toronto where they proved, for the very first time, that neural networks actually work at scale. So, you aren't just exploring some dry history lesson today. This explainer is quite literally the origin story of the world you're living in right this second. The technology that sparked to life on those 2 gaming GPUs is only evolving faster. The real question is, are you ready for what's next? If you love diving into these quiet, behind-the-scenes moments that radically changed everything, hit that subscribe button. That's exactly what we do here, breaking down the world's most important ideas one explainer at a time. Thanks for hanging out with me today.